Alright, this is Chapter 2, Section 6. So we're going to identify the distribution based on mean, median, and mode, essentially. So if it's skewed left or right, that's going to basically be a calculation of mean and median as a good indication. If the mean, oops, where's my marker here? There we go. If the mean is less than the median, right, then it's skewed left or negatively, although negatively is a better one because, sometimes graphs go up and down. So they would be down, skewed left, or down, depending on which way the graph is put. If the mean is greater, right, it's either it's skewed right, right? So essentially you want to look at the mean and the median, right? Is the mean and the median, is the mean on the left, or is the mean on the right, essentially, right? What's the case? Or are they in the same place? That's essentially what's happening, right? So you either skewed left, skewed right, or you're symmetrical, which means they're approximately the same, essentially. And the reason being is basically the mean is the bully. Think like the mean bully, right? If there's an outlier, it's going to pull it in a direction. So the outlier is going to pull the mean in one direction or the other, and that's why it's going to look skewed, essentially. Okay? All right, so if we go down to here, and we look at this data here, this looks approximately symmetrical, which means the mean and the median are probably about the same. So if I calculate the mean and the median here, what I'll notice is that I get 7 in both cases, which is approximate. So they're both about 7. The middle value is 7. If I add them up and divide by 16 the values, I still get 7, right? Versus if I have this one here, this appears to be skewed to the left, or negatively skewed, because again, sometimes graphs go up and down, so saying left isn't the best thing to do, but the book does. Which means if there's an outlier, or there's outliers over here, or maybe outliers over here, that's pulling the mean this way, right? Which would tell me the mean is less than the median, basically. So if I line them all up and add them all up and figure out the calculations here, effectively what I'll get is I'll get 6.3 for the mean and 6.5 for the median, which means the mean is less than the median. So yes, it is negatively skewed in that direction, so that is the case. Versus this last one, this is clearly skewed to the right. It's being pulled or stretched to the right, which tells me that the mean is going to be to the right of the median, essentially, when I do my calculations, right? So if I do my calculations, and if I add all those numbers up, and I divide by 10, I'll get 7.7. And the middle value is between the 7 and 8 there, because there's, 10 values. So between those two right there, which would be the 5th and 6th value, you get 7.5. So in fact, the mean is slightly bigger. Obviously, you typically have bigger data sets than these. 10 is not very many values. Okay, so either approximately symmetrical, approximately skewed left, or approximately skewed right, or positively skewed, essentially. Okay, and it's not just histograms. It can be anything that shows dot plots, anything that shows a distribution, basically. So dot plots do it. So let's say I take these 3 data sets here, and I make dot plots. Well, let's do that. So I'm going to make dot plots, copy, and we'll make dot plots here, which I drew ahead of time. Okay, so this dot plot, if I look at it, is clearly skewed to the right, and there's some outliers out here, so it's pulling the mean out here, which means the median, or the middle value, is probably over here. So if I order these up and figure out the middle value, I'll get 3 as my middle value, and if I add them all up and divide, I'm going to get 3.7, which makes sense that the mean is bigger, right? So therefore it's skewed to the right, or positively skewed. Versus this one here, these are all pretty bunched up over here. So if I do my calculations, what you'll notice is I get a mean of 2.8. So I'm being pulled over here, basically, right? And the median is 3. So it's negatively skewed, but not very much. Not very much at all, because they are kind of bunched up, but it is definitely being trailed off this way, right? So definitely being skewed to the left a little bit, but not a lot, because skewness could be a lot or a little. This one's clearly a lot. This one's very little. Okay, versus this one over here, if you look at the picture, it's actually perfectly symmetrical. right? It's perfectly symmetrical. And if I figure out the middle value, it's between 4 and 6, which is 5. And if I add them all up and divide, I'm also going to get 5, which would tell me it's basically approximately symmetrical, essentially. All right? Okay. So, is dot plots and histograms the only ones? No. I mean, we did stem plots, right? Remember, we did stem plots. This stem plot looks symmetrical, right? This dot plot, which I used X's and dots this time, is pulled to the right. And then this histogram is pulled to the left, right? So what should we know? This one should have a mean bigger than the median, right? This one should have a mean and a median approximately the same, right? And this one, the mean should be less than the median, right? Because it's being pulled this way, right? Because the mean is the bully. It's being bullied by the outliers, right? Or it's bullying the outliers, probably bullied by the outliers, probably a better way to say it. So it's pulling it in a direction, essentially. So outliers affect mean. It does not affect median, because median is just the middle value. So however big the endpoints are really don't matter. It's the middle of the values, essentially. Okay, so we don't know what the exact answers are as far as calculations for any of these three graphs necessarily without doing any math. I don't need to do the math. I can figure out the relationship between the mean and the median just by looking at the graphs, essentially, okay, and making a general estimation as to what I think.